Okay, so now we've calculated the three types of power that you're going to get in your circuit. Remember, once again, the true power always comes from the resistor, and it's always on the horizontal line of your triangle. The reactive power always comes from the inductor, and it's always on the vertical line of the triangle. And the apparent power is the overall power in the circuit, and it's always the hypotenuse of your triangle. So these are the values that we calculated for those three. The last calculation that we do is the power factor. And the power factor gives you an idea of how efficient your circuit is. So of course you want a high power factor. So let's calculate that. In order to calculate the power factor, you get the resistance of your resistor and you divide it by the impedance of the overall circuit. And once you get that fraction, you just multiply by 100 and that gives you a percentage. So let's do that. If you get the resistance for the resistor, let's go back, it's 60 ohms. And the impedance is 1885.90. And all of that multiplied by 100. So let's see what we get. 60 divided by 1885.90 times 100. So if you got the number that I got, which is 3.18%, this circuit is not very good. Obviously, it's not very efficient. At 3.18, the power factor is not very good. You want something that's up in the upper 90s in terms of percentage. So 3% actually is not very good. Another way that you can get your power factor is to go back to your power values. And you do the same thing. You get the power for the resistor. Excuse me. The power for the resistor is 0.238 over the overall power, 7.485. And then you multiply that times 100. Let's see if we get the same thing. So 0.238 divided by 7.485 times 100. And lo and behold, I get 3.17%. So as you can see, there's different ways in which you can get the power factor for your circuit. If you have all the power values, then you can use the power combination, the power from the resistor divided by the overall power of the circuit gives you the same percentage. Then if you use the resistance of the resistor over the impedance of the entire thing, you get the same, almost the same value, 3.18%. Okay? This is basically all the calculations that you need to make for your combination circuit that deals with a resistor and an inductor in series. On the next lessons, we'll discuss a resistor with a capacitor, and the mathematics are very similar.